Last class, we were discussing linear and quadratic systems of equations. Today, we're going to go with the three variable systems of equations. We're going to start that with a word problem. So your club sold tickets to a special viewing of a new movie. The fundraiser was successful. You sold all 800 seats in the school's auditorium. You sold tickets at three different prices: $2.50 for children under 12 years old, $3.50 for youth between 12 and 18 years old, and $5 for adults. The total amount of money taken in was $2,937.50. And there were 4 times as many youth tickets as children's tickets sold. How many of each type of ticket were sold? This problem has a lot of information, so the first thing you're always going to want to do is to define your variables. Be sure to define those variables. That helps you write the equation. It also helps you to understand the answer once you find it. So it asks us how many of each type of ticket were sold. That's my unknowns. That's what my variables are going to be. And so we saw in the problem there were 3 different tickets. There were the children tickets, the youth tickets, and the adult. So we'll say X is going to be my child tickets. Y will be the number of youth tickets. And Z will be my number of adult tickets sold. Once we define our variables, now we start to write the equations. If we have 2 unknowns or 2 variables, we need 2 equations. If we have 3 unknowns or 3 variables, we need 3 equations, and so on. If you had 4 variables, 4 equations. So in this case, we have 3 unknowns, 3 variables. So we are going to write 3 equations. That's what we need to solve. One of the things you want to look at here, it gave us a total amount earned and how much each ticket costs. So one of the equations is going to be that cost equation. So our child tickets were $2.50. So we could say $2.50 times each child ticket. My youth tickets were $3.50. So I could say $3.50 times each youth ticket. And my adult tickets were $5. And that came out to be $2,937.50. So now that we have our cost equation, now we can do our total equation. It said we sold 800 seats in total. So the number of child tickets plus the number of youth tickets plus the number of adult tickets should give me 800 because that's how many we sold in total. Now, that gives us 2 equations. We still need 3 with 3 unknowns. So we look at this last part where it says there were 4 times as many youth tickets as children's tickets sold. That's a confusing line for students to change into an equation. That's where defining your variables really comes into play. So we think about this. If there were 4 times as many youth tickets as children tickets, that means there were more youth than child. And so my youth tickets has to be equal to 4 times my child tickets. Whoops. That's an X. So there we go. Y equals 4X. So now we've written our 3 equations. Now we can start solving. Just like we did with the 2 variable systems and the linear and quadratic systems, the methods are the same. We can do substitution or we can do elimination. In this case, using substitution is probably the easiest. So we solve one equation for a variable, and then we substitute it into the expression in the other 2 equations. This reduces a system of 3 equations and 3 variables into a system of 2 equations and 2 variables. Now, in this particular case, we got lucky because they've already solved for y in this last one. So in the equation y equals 4x, it's already solved for y. We can substitute that into the other 2 equations to create a 2 variable system. So we're going to do that. We get 2.5x plus 3.5, and this is where I'm going to go ahead and plug that in. So y equals 4x, so y is the same thing as 4x, so I'm going to take the 4x and I'm going to substitute it into the y there. So this changes to 4x. Everything else in the equation stays the same. So there's our new equation. 2.5x plus 3.5, our new y, plus 5z equals 2,937.50. We can go ahead and simplify that now. So we're going to multiply our 3.5 times 4x to simplify this. And now we combine our like terms. And so we can add these two together and we get 16.5x plus 5z equals 2,937.50. This equation now has two variables. We need to do the same thing now to our other equation, the x plus y plus z equals 800. So I'm going to take that 4x and I'm going to plug it in for this y. So we substitute this y with 4x. Everything else in the equation stays the same. We combine our like terms, and now that has two variables as well. So we've got a new system. Our resulting system is the two new equations. So this was actually the algebra 2 part up here. When we took away the third variable and we went to the 2 variable, we're back at our algebra 1. And so now we have to do substitution or elimination again. You can choose whichever method you find easier. So you can solve for a variable and plug it in, or you can do elimination. I think this one's a good one that's set up for elimination because this z has a coefficient of 1, so we can easily make these the same number with a different sign. So I'm going to multiply this second equation times a negative. That gives me negative 5x. I'm sorry, I need a negative 5 there. We want it to have the same exact number with a different sign, so I need to multiply it times negative 5. And so negative 5 times 5x gives me a negative 25x, negative 5z equals negative 4,000. So I have multiplied this negative 5 times everything in this equation to get this new one. This equation we don't have to change. It already had the 5z. And so I just rewrite it so that they're all lined up. And we're ready to add. Now when I add, the 5z and the negative 5z is going to cancel out. So we can go ahead and cancel those out and start to add. 1650 minus the 25 gives us a negative $8 or negative 8.5x. And then we do the same thing for our final numbers. So we've got 2937.50 minus the 4,000. And then our last step, now we've just got one variable, so our last step is to divide by that negative 8.5. And we get 125. So now we've sold 125 child tickets. That's what this is right here. That's why we define our variables so that we can always go back and see what does the X stand for. It stands for the number of child tickets sold. So we have 125 children's tickets sold. Now with systems of equations, we don't stop there, because we had 3 unknowns, not just one. So we want to go back and find the rest of the values for this. And so we plug it back into either one of the equations. And so the first one I'm going to plug it into is right here. Y is equal to 4x. So I get y equals 4 times 125. That's going to give me the number of youth tickets. And then the last one that we have to go back for is the adult tickets. And so you can pick any one of the equations up at top to find those. I think the easiest one is going to be the x plus y plus z equals 800. Now we know that x is 125. We know now that y is 500. We are looking for our z, and in total it was 800. And so we can combine our like terms. And so we get z equals 175, and that is the number of adult tickets sold. And so we've solved the three variable system. This does take a lot of space on your paper there, and you want to keep it as organized as possible. So try and line up those equations as much as possible so that you don't get confused through it. Again, we'll go over summarize those steps. Step 1, you're going to define your variables. However many variables you have, you're going to write that many equations from the information given in the problem. And then we start with substitution or elimination to get rid of one variable at a time. All right, let's try another one. All right, so during the movie fundraising event, the concession stand at the auditorium sells popcorn, candy bars, and drinks. The price of a box of popcorn is 50 cents more than a candy bar, and the price of 2 drinks is 50 cents less than the price of 3 candy bars. You order 2 boxes of popcorn, 1 candy bar, and 3 drinks, and the total comes out to be $7.75. Formulate a system of 3 linear equations and 3 variables to represent this situation. Be sure to define your variables. Always start with that defining of our variables. All right, so in this case, I'm going to go ahead and call P is popcorn. And that is the price. The next one is candy bar, so C will be my candy bar. And the last one is the drinks, and so I'll call that D. So there's my 3 variables, the price of the popcorn, the price of the candy bar, and the price of the drinks. And so now we're going to write our equations. We know that we need 3 equations because we have 3 variables. The first one, the price of a box of popcorn usually means equals. So popcorn equals 50 cents more than a candy bar. So my candy bar price plus 50 cents, because this would be 50 cents more than the candy bar. Now we've got one equation, 2 more to go. The next one says the price of 2 drinks so 2 drinks which is our equal to, 50 cents less than the price of 3 candy bars. So 3 candy bars minus 50 cents. That's 50 cents less than 3 times the candy bar price. We've got 2 equations, one last one. The last one says you order 2 boxes of popcorn, so 2 times the price of the popcorn, 1 candy bar, so plus the candy bar price, and 3 drinks, so 3 times the price of the drinks, and it equaled $7.75. Now we've got our 3 equations. This one too is set up for substitution. It's an easy one to do substitution because P is already solved for here. So we can plug in P here and get rid of that P value. So let's start with that. We get 2, and then I'm going to use parentheses for this P, and I'm going to plug in our new one there, C plus 0.50 plus C plus 3 times D is equal to $7.75. All right, so when I've plugged in this p, I'm going to get rid of the p in this equation. It's only going to be c and d, which is what's in the other equation. So it makes it a little bit easier. So that's why we started with that substitution. We are now going to distribute, and so I get 2c plus 1 plus c plus 3d is equal to 775. I combine my like terms. I've got a 2c and a c, which is 3c plus 3d. And I'm going to subtract this 1 to get it to the other side. So I get $6.75. I've now got an equation, 3c plus 3d equals 675. I'm going to use this one with this other equation now. I use this one to substitute, so I need to use this one now in order to get the two variable system with this one. So I'm going to rewrite 3c plus 3d equals 6.75. And then I'm going to bring this one down. And to do that, quick note, I'm going to go ahead and put it into the standard form like this one here so that they can line up together. So here we've got the c and d on one side of the equation, everything on the other side. So I'm going to subtract this 3c to get it to the other side. So I get 3c plus 2d is equal to negative 0.50. Now I can line it up nicely with the other equation. Time to do my elimination. So we did substitution initially to get down to the two variables. Then you need to choose a method at that point. And you can do substitution again, or you can do elimination. You don't have to do the same one. So I'm going to do elimination here. This cancels the 3c minus 3c. We get 5d is equal to $6.25. Now it's time to divide, so we could get that d by itself. So 6.25 divided by 5 is 1.25. So the drink price is $1.25. It's actually a bargain right now. Now we never stop there. We want to go ahead and find the other two values. And so you can choose to plug it into either equation. Since we have the d value, the easiest one to plug it into is going to be this one right here, because then I can find the c value. So 2 times $1.25 equals 3c minus 0.50. This gives me $2.50 equals 3c minus 0.50. I add the 0.50, so we get 3 equals 3c. So c is 1. So the candy price is $1. Also a bargain. All right, we've got one variable to go. For my last one, I need the value of the popcorn. And so obviously this is going to be the easiest one to plug that back in. It doesn't matter which equation you use, when you plug them back in, you're going to get the same exact value. So just pick which one that you think is the easiest. So this one's going to be the easiest for me. Popcorn is equal to the candy price, which is $1 plus the 50 cents. And so our popcorn is $1.50. All right, we've solved another 3-variable system there. Summarize our steps again. Always define your variables. However many variables, that's how many equations you need. Once you have that, you can start with substitution or elimination to get down to 2 variables, then do the 2-variable system and start to substitute back to get the rest of those. All right, so now we're going to do a problem that doesn't come from a word problem so that you know how to do those as well. So we've got a math problem that they came up here. It's a 3-variable system. And so we're going to solve this problem. This one, they did us a favor because the second equation only has 2 variables. So we can do substitution, we can do elimination, either one. I wouldn't do substitution with this one because each one of these variables has a coefficient, so it's going to make it harder to solve for. I would definitely pick elimination on this one, so that's what we're going to do. So in this case, I would want to eliminate the z's because it's already eliminated in the second equation. So we're going to try and eliminate it with these two as well so that we can have a second equation. This one has a coefficient of 2, this one has a coefficient of 4. I need them to be the same number with a different sign. That's what we do when we do elimination. So I'm going to multiply this top one times -2. So that gives me -10x, -6y, minus 4z is equal to a positive 6. I multiplied the entire equation times -2. You have to do it to both sides of the equal sign and all of it so that you're not changing the value. The other equation, we don't have to do anything to it because it already had a 4. There's not one way of doing these equations. Sometimes you guys are going to pick different variables to do it. That's okay. You're still going to end up with the same answer as long as you do it correctly. All right, we're ready to add this. So -4z plus 4z is 0. So this cancels out. -10x and 2x is a -8x. -6y and -3y is a -9y. And 6 and -14 give us a -8. So now we've got a two-variable system. It's got x and y's. We're going to use this equation, the one we just created, by adding the other two together with the original second equation. Oops, that was a minus. And we're going to do the same thing now. We need substitution or elimination. This is an easier one to do with elimination because all of the variables have a coefficient. So I want them to be the same number. So either one of these actually works. You can get the x's to cancel by multiplying this bottom one times 2, or you can get the y's to cancel by multiplying it times -3. So I'll go ahead and multiply this one times a -2. Sorry, a positive 2. They need to be the same number with a different sign. So we need to keep it as a positive 2 so that these have different signs. This one just comes over. Here we multiply, so we get 8x minus 6y is equal to 8. We add, and my -8x and 8x is 0. That goes away. We add here, and we get -15y is equal to 0. I divide by -15, and I get y is equal to 0. So we have solved for the first variable. To get the next variable, the easiest thing for me to do is plug it into that second equation. That's going to allow me to solve for x. So I'll do that right here. 4x minus 3 times 0 equals 4. 0 times anything 0, so we get 4x equals 4. And so my x value is 1. Last step, I need the last variable, which is z. I pick either one of these equations that has a z. Whichever one you choose is fine. I'm going to go ahead and take that last one. And so I get 2 times 1 minus 3 times 0 plus 4z is equal to -14. That's 2 minus 0, because anything times 0 is 0. So we get 2 plus 4z equals -14. I subtract the 2, and I get 4z equals -16. So z is -4. We have solved the 3-variable system. These are time consuming and it takes a lot of details, but I know you can do it. It's probably time for you to try one, so if you want to pause the video here and try number 8, and then you can come back and see if you got it correct. That'll allow that gives you a chance to try it. Math's not a spectator sport. All right, here we go. Again, they made this one easy. The last one doesn't have a z value, so that's already eliminated there. Now we need to eliminate z using these top two. In fact, they made it even easier because it already has the same coefficient and different signs. So we're ready to go with them. I don't have to multiply them times anything. I'm just going to move them to the side. So I get x plus y plus 2z equals -7. And 3x plus 4y minus 2z equals -10. I'm going to add these two together. So this cancels. Positive 2z and negative 2z is 0. I add these. X plus 3x is 4x. Y plus 4y is 5y. And then -7 and -10 is -17. I've now got a two-variable system. I'll rewrite it over here. We have 4x plus 5y equals -17, and then x minus y equals -2. That was the Algebra 2 portion right there. We eliminated one variable from all three equations. That's the Algebra 2. Then we go to the Algebra 1 where you're finishing up the system of equations you learned then. You can do substitution or elimination here. We haven't done much substitution, so why not try that? X is equal to y minus 2. I added this y to get it to the other side. Now I know that x is the same thing as y minus 2. So I can plug that in right for the x in the other equation. So we get 4 times y minus 2 plus 5y equals -17. I distribute. I combine my like terms. And so we get -8 plus 9y is equal to -17. We're going to add that 8 to get it to the other side. So we get 9y is equal to -9. And we divide by 9, and so we get y is -1. We have found the first variable. For my second one, I'm going to go ahead and plug it right here because that's going to make it the easiest. So I get x equals -1 minus 2, which is x equals -3. My last one is to go back and plug it into either one of these top equations that has the z. I'm going to go ahead and plug it into the very top one. So my x is -3, my y is -1, plus 2z equals -7. I combine my like terms. I'm going to add this 4 to get it to the other side. So we get 2z is equal to -3. And then I divide by 2 and I get -3 over 2. If you did that with elimination, that's great. You'll get to see that they come out to be the same exact answer. Doesn't matter which method you pick. All right, that was 3 variable systems.